Now let's dive into the concept of scalar multiplication of matrices. As you can see on the slide, scalar multiplication involves multiplying each element of a matrix by a scalar value, which is just a regular number. The matrix on the left, for example, has elements A, B, C, and D, and is multiplied by a scalar, which we are calling K. The result of this multiplication is a new matrix where each element is multiplied by K. So A becomes Ka, B becomes Kb, and so on. This is a simple element-wise operation. Now let's discuss some important properties of scalar multiplication. The distributive property shows how scalar multiplications distributes over matrix addition. If you have two matrices A and B, if you multiply them by the same scalar K, you can distribute the scalar over the sum of A and B, and you can write this as K bracket A plus B close bracket equal to K A plus KB. The associative property means if you have two scalar K and M multiplying a matrix, you can group the scalar together first, or you can multiply them one time at a time. This result will be same either way. Basically, if you have K multiplied by M for both scalar and multiplied by A, it's the same as you doing a multiplication of the scalar M with the matrix A first, followed by K with the result of this matrix. Finally, we have the identity property, which is very simple. If you multiply any matrix by the scalar 1, the matrix is left unchanged. In other words, 1 multiplied by a matrix is just the matrix itself. You can represent this property as 1 multiplied by matrix A equal to matrix A. Now let's spend some time to answer this scalar multiplication question. It is said in the primary school store where exercise books and pens are sold to a few different levels, primary 3, primary 4, primary 5. Please take a minute to look into this. Feel free to pause the video and then resume when you have finished the question. Now let us solve the problem step by step. We first want to represent the surprise distributed by Mr. Tan and Mrs. Lee as matrices A and B. For matrix A, this is a surprise distributed by Mr. Tan in first week. So matrix A will have 2 rows for exercise books and pen, and 3 columns for primary 3, 4, and 5. We can present it as A equal to 100 for the first element, 80, 90 for the first row, and then we have second row 70, 60, and 50. And then we have for Mrs. Lee, let's define a matrix P, and we can have the first row as 120 for the exercise books, 110 and 100. Then we have 90, 85, 75. Calculate the total number of exercise books and pen distributed to each level by finding 2A plus 6B. So this is also pretty easy. You just have to find 2A plus 6B, right? So what's 2A? 2A is just 2 multiplied by the scalar above. So you know this is 70, 60, 150. So for every element, you just have to multiply by 2. And then so you got 200, because 200 is 100 multiplied by 2, 160, 180, and for the second row, you have 140, 120, and then 100. And for 6B, you have 6 multiplied by 120, 110, 100, 90, 85, 75 here. So you have 720, 660, 600, 540, 510, 450. And when you sum them up, it's just a element-wise operation. So 200 plus 720, 920, 110, sorry, 160 plus 660, 820, 180 plus 600, 780, 140 plus 540, 680, 120 plus 510, 630, 450 plus 100 equal to 550. Notice that when we do addition of two matrices, the matrix had to be in the same order. In this case, both of them are of order 2 by 3, meaning 2 rows and 3 columns.